Generative AI. The development of generative AI resembles the creative revolutions brought by photography and film. While photography allowed us to capture reality without an artist's interpretation, generative AI enables anyone to draw, sing, or create content without traditional skills. Now, in a matter of seconds, we can obtain succinct information. Additionally, we are able to automatically create text, including product descriptions and news stories. We are also capable of creating personalized furniture or shoes. Using algorithms trained on pre-existing data, we can generate visuals, speech, music, 3D objects, and sound effects. These machines are becoming round-the-clock helpers that can fulfill a range of duties on our behalf, enabling our vision to be realized nearly instantaneously, freeing us from tedious tasks and allowing focus on strategic and creative work. Even though generative AI gained widespread attention in 2022, its development has a very rich and fascinating history marked by significant breakthroughs. Its evolution was built on decades of mathematical research, beginning with autoencoder neural networks in 2006 and continuing through the widespread adoption of generative AI models today. Along with the expansion of suppliers and services, there has also been a significant improvement in the quality of output. These days, we could just input any term into the computer and get meaningful results. Generative AI is a powerful tool deployed in many fields such as art and medicine. Having knowledge about how these models operate will help us to better employ them for solving problems with new innovative ways. Generative AI keeps getting better, and we should expect more amazing results. Generative AI versus other types of AI. The main difference between generative AI and other forms of AI lies in their goals. Other kinds of AI also have numerous applications, but they are usually used for tasks like prediction, classification, clustering, and regression. They take in data and provide specific output based on this data. For instance, a classification model could predict if an email is spam or not. Another factor that sets apart generative AI from others is the fact that it is creative and has different applications which are not possible with other types of AIs. It generates new data that looks like the inputted data. Some of these include creating artworks, composing music pieces, writing text, among others. For instance, after learning from a data set of songs, a generative AI model can create a new piece of music. Also, generative AI can be utilized for generating additional data, which helps out when there's limited amount available during training other AIs. While they might still produce information, other kinds of AI achieve this as a byproduct. The major output of generative AI is enshrined in the creative process. Generative AI aims to do exactly that, whether it's with text, images, product recommendations, or whatever. How generative AI works. Generative AI is one branch within artificial intelligence that uses machine learning techniques to produce data, which resembles the input data. It can be textual language, images like pictures taken by a camera or paintings drawn on canvas, music, and even voice. Generative AI does not only analyze and understand data, but also creates new such like ones, which are born similar but different from what has been seen before. The heart of generative AI lies in generative models. They learn the true data distribution of the training set so as to generate new data points with some variations. Modeling the joint probability between target variables and observed ones makes these models to produce new instances based on this learned probability distribution. You educate an algorithm to produce outputs and solutions by feeding it with thousands, millions, or even billions of pieces of content. Teams of highly skilled mathematicians, computer vision specialists, and machine learning experts write and build these AI models, which are akin to specific subjects and tasks. They are typically supported by businesses and academic institutions and are based on years of open-source machine learning research. Several of the major contributors to these generative AI models engines are OpenAI, NVIDIA, Google, Meta, and universities like UC Berkeley and LMU Munich. These include a wide variety of generative models such as generative adversarial networks, (GENs), variational autoencoders, (VAEs), restricted Boltzmann machines, RBMs, and many others. GANs work together in two-part harmony by developing a generator and a discriminator. In this duet, the generator makes up new data instances, while the discriminator tunes in and appraises them for authenticity. VAEs are a type of autoencoder that incorporates a bit more complexity. Instead of encoding an input as a single point, they encode it as a distribution over the latent space. RBMs are one of the recurrent network types used for purposes of dimensionality reduction, classification, regression, collaborative filtering, learning features, and topic modeling. There are several key components in how generative AI works. First, data should be collected and pre-processed to finally train the generative model. The second step is choosing a specific model, such as GAN, VAE, or RBM described above. The model trains in an iterative way, changing parameters based on the results, until it's well trained. Using proper training, the model can generate fresh data from converting random seeds into insights. Quality and diversity are finally checked through the generated data, either with the help of various metrics or by human reviews.